So our today's topic is vectors. Okay, so we completed error analysis, we completed measuring instrument, and last week we completed unit and dimensions. Okay, there we have seen that physical quantities are divided into fundamental and derived quantities. So 7 fundamental quantities we discussed along with the 2 supplementaries, and then the remaining quantity we call derived physical quantity. So that was one category in which we were dividing physical quantity. Today we will divide physical quantity in another category, which is scalar and vector. So let's understand what are scalars and what are vectors. So physical quantities we are dividing into 2 ways: scalar physical quantities and vector physical quantities. There is one more type of division, that is called tensor quantities. So right now we do not have tensor in our syllabus, so we are just discussing scalar physical quantities and vector physical quantities. So all the physical quantity we will come across, we will divide into 2 categories, scalar and vector, right. So what are scalar quantities? So to understand that, let's see one small animation. Like there is a particle which moves and covers 8 meter distance. So here on xy plane 1 meter gaps are there, and similarly 1 meter gaps are there along y axis, right. Now so particle moves from this point to this point. Let's say particle takes 5 seconds to reach there. If I ask how much is the distance covered, so distance covered by the particle, you will write distance covered, you will write 8 meter, and this is a complete information. If I ask how much is the distance covered, you will say particle covers 8 meter distance, and this is a complete information. And if I want to give extra information, 8 meter in what direction, because particle is going along x direction, right, it is not going this way, it is not going this way, it is not coming along negative x direction or negative y direction. So I will add one more information in this one. I will say 8 meter along positive x axis. So the first one, distance, is a scalar quantity, and second one, this is called displacement, which is a vector quantity. So vector quantity will have 2 informations. One is magnitude, this 8 meter is magnitude, and this along positive x direction is direction. Magnitude, so the physical quantity which require magnitude as well as direction for their description comes under the category of vector, and those physical quantity which just require magnitude for their complete description is called scalar quantity. So scalar and vector. So all the physical quantity we will divide into these categories. Scalar, we have already seen how to add scalar physical quantities. Like if I talk about the mass, you have 2 kg potato and 3 kg potato, and what is the total mass? So you will just add 2 with 3 and you will answer that 5 kg. But this is not the way we can add vector quantity. So vector quantity, addition, subtraction, multiplication, division is totally different as compared to the multiplication, division for scalar quantity. So vector, how to deal, that we will see later, but for time being, from this example I hope this is clear. So there is a physical quantity which just require magnitude for complete description, while there is a physical quantity which requires magnitude as well as direction for their description, right. Similarly, if I take the movement of this particle, look at this, it follows path something like this and comes to from origin at 7 meter, right. So in this situation, if I ask what is the displacement of this particle, so the path it follows, the path you can see, the path it is following is something like this, and finally it is getting to this point. So if I ask what is the displacement, you will say 7 meter along negative y axis. Previous case it was along positive x axis, now in this case it is negative y axis. So this is the displacement of the particle. Okay, so from origin it has reached to this location. In the same situation, if I ask how much is the distance covered by the particle, so you will find out the total length of this path, that will give you distance. So length of this path, length of path will give you distance covered by particle, right. So same way we have other physical quantities which might require only magnitude for their complete description, or which may require additional information about direction for their complete description. Those quantity will be called vectors. So let's see scalar first. So you can see temperature, we are measuring temperature with thermometer, and say temperature of this room is 28 degree centigrade. So 28 degree centigrade is the complete information, right. So temperature is requiring only magnitude for its description, it is scalar quantity. So temperature is scalar quantity. Similarly, if I ask what is our time right now, so say 6:45. So 6:45 is a complete description of time. You don't need any other additional information. So time is a scalar quantity. Similarly, mass is a scalar quantity, like mass of this gold bar, say 1 kg. So 1 kg is the magnitude, and this is a complete information related to the mass of this object. Okay. So length, mass, time, temperature, density, volume, these all are scalar physical quantities, right. Now let's see vector physical quantities. Okay. So previous case you can see the definition, a scalar physical quantity has only magnitude for their complete description, while in case of vector they require magnitude as well as direction. Okay. So position, for example position. So from your home, if I ask what is the position of a sweet shop, right. So you need to tell the direction towards north, towards south, south of north, 30 degree north of south, right. So along with the distance, say it is shop is at 2 km from your home and it is along or due north, right. So you have to tell that position of shop is 2 km due north. So position, for complete description you require direction as well as magnitude, right. Similarly, force, for example say this boy is exerting force 5 Newton. How I will describe the force? I will say 5 Newton towards, if I say this is positive x axis, towards positive x axis. So this boy is exerting force in this direction, say 6 Newton. So for this boy I will write it is 6 Newton, force is 6 Newton along negative x axis. So along with the magnitude of force, I am giving additional information which tells us about the direction in which force is acting. So this force is acting along positive x direction, this force which is 6 Newton is acting along negative x direction. Similarly, velocity or acceleration, say this man is running with velocity say 2 meter per second due east. So 2 meter per second is the magnitude of velocity and due east will give you the direction of velocity. So position, velocity, acceleration, all these quantities are vector. Force I already discussed. Momentum, which is mass into velocity, later we will discuss, that is also vector quantity. So there are other quantities which are vector, that we will see later, but for time being, position, displacement, velocity, acceleration, momentum, force, these are vector quantities. Mass, time, length, temperature, kinetic energy, potential energy, energy, work, these quantities are scalar physical quantity. Only one information is sufficient to completely express them. Here both direction and magnitudes are required to completely express them. So I hope the difference between vector and scalar is clear. Okay. Now, so how to represent a vector? Any vector quantity is given to you, how to represent it? For that, what we do, we draw one arrow. Okay. So the end, this end is called tail, and where we are keeping arrow, that is called head. The length of this one is magnitude, is representing magnitude. So length of this part is magnitude, and along the direction of this arrow we tell that is the direction of vector quantity. So any quantity which is vector, for example force is vector, so how we will represent force in vector form? F, we will put arrow over it, this is representing force which is a vector quantity, right. Similarly velocity, so velocity I will put arrow over it, this will be representing vector quantity. So any physical quantity which is vector, what we will do, we will put arrow over it, and the whole thing represents the quantity we are talking about is a vector quantity. And graphically how to represent it? Just draw a line, put arrow, okay, in such a way so that it will be in the direction of that particular vector. So from this one we can have magnitude, the length of this arrow, and the direction of this one can be find out with the help of head. So this is the graphical representation, and symbolically we represent vector this way, right. Now we will talk about terms which we will be frequently using while describing or comparing vectors. So let us first see unit vector. I gave you example like a boy was exerting force, 5 Newton force along positive x direction. So 5 Newton is the magnitude and along x is the direction, right. So along x just gives me direction. Up force can be in that direction, velocity can be in that direction, momentum can be in that direction, any vector can be in that direction. So unit vector represents the direction and its magnitude is always 1, right. So unit vector, if I know the direction, I know the magnitude, I can describe vector. So two things are required. So here A cap is called unit vector along A vector, and this A what I am writing, that is magnitude. Magnitude can also be written as A vector mod. So this way you can write, or you can also write A vector mod, this also represents the magnitude of A. Magnitude of A vector, right. So I need magnitude, I need direction to completely describe that. This direction part is called unit vector. If you look at this expression, this can also be written as A unit vector is A vector divided by mod A. So if I take the same example, 5 Newton force is acting along x axis, here this is 5 along x axis and it is divided by 5, that means this magnitude will be 1. So the magnitude of unit vector is always 1. This is the way we write magnitude, mod A unit vector, its value will be 1. And as you can see, here I am writing force and here I am writing force, or here I am writing velocity, then I am writing velocity here, right. So unit will get cancelled out this has to be dimensionless and unitless. So unit vector will have magnitude 1 and it won't be having any unit or dimension. So unit vector are dimensionless vector of unit length. Okay. So how to use unit vector, that we will see later in the representation of the whole vector in 3 dimension, that we will see later, right, how to use it. But for time being, unit vector name is clear, unit vector magnitude 1 and it has to be dimensionless. Okay. Now let us see next one. So when you want to compare direction, or when you want to compare magnitude, when you want to compare the whole vector, what are the terms involved? Let us see. So if I just use the unit vector here, so this is a vector and it will have unit vector this way along A, it will have unit vector. Now if I multiply this to some scalar, then magnitude will get magnified by the same amount. So if I am multiplying it by 3, then it will get magnified to 3 times. So now 3a vector will be represented like this, and if I multiply it to minus 3, so if this is a vector, minus a vector will be in opposite direction, and then I multiply this quantity to 3, this 3a with minus sign vector, minus sign a vector, it will be like this. So if you multiply any vector to negative multiplier, the direction will get reversed and it will get magnified by same amount. So minus 3 a vector will be like this. In all the cases, the unit vector will be in the same direction. All are having same direction, unit vector A, unit vector A, unit vector A. Only thing you have done, you have multiplied to different quantities, right. So I hope this is clear. The multiplier changes the length and the sign indicates the direction. Okay, so with negative sign if you multiply, direction will get reverse. Positive sign if you multiply, then direction will remain same. Only thing, it will get magnified or diminished depending on what multiplier you are multiplying with. For example, if I multiply it to 1 by 2, then 1 by 2 it will become half of this length. So this will be representing a vector by 2. Okay. Now let us see next one. Second name is parallel vector. So when we are comparing two vectors, right, they are called parallel vector if their directions are same. So if I apply force on a particle, its acceleration is coming in the same direction. So acceleration and force both will be parallel vector, right. So I can compare two vectors, they may or may not be representing same physical quantity, may or may not represent same physical quantity. So here one can be force, another can be velocity, one can be force, another can be displacement, force, momentum, any combination you can have. So you can say two vectors are parallel, only condition is their direction must be same. So for direction of this one, this direction I can separately write a cap, and similarly direction of B I can write b cap. So if two vectors are parallel, then a cap must be equal to b cap, right. If they are representing same physical quantity, then we can compare whether they are parallel or not. Even if they are not representing same physical quantity, then also we can tell whether they are parallel or not. Only requirement is their direction must be same. So anti-parallel vector, obviously if parallel vector they have got the same direction, anti-parallel vector will have different direction. So again this is the condition, they may represent the same physical quantity or may not represent the same physical quantity. Now look at this one, this will have A cap in this direction while this will have B cap in this direction. As you can see, both are in opposite direction. So how I write it? A cap, direction of A is reverse to the direction of B. Okay. So if two vectors are parallel, then A cap will be equal to B cap. If they are anti-parallel, then A cap will be equal to negative B cap. Okay. Now equal vector. When we say equal, we are comparing two vectors, and we can compare two vectors only if they represent same physical quantity, right. So only if they represent same physical quantity. So force can be compared with the force, velocity can be compared with the velocity, right. For equal vector, you cannot compare force with the velocity or force with the acceleration. They must represent the same physical quantity, then only we can talk about the equality of the vector. So when two vectors are equal, their magnitude must be same, their direction must be same, then only they will fall in the category of equal vector. So how we write it? A vector is equal to B vector. Okay. What we understand from this? A vector mod will be equal to B vector mod. And what else we understand? That A vector direction must be equal to B vector direction. So I hope you are understanding the basic difference between the previous one, what I am writing here, that their directions are same. There is no meaning of comparing magnitude because they are representing different physical quantity. Here, as they are representing same physical quantity, equality means their magnitude must be same and their direction must be same, right. Negative vector, right. So opposite to this one. So if A vector is in this direction and B vector in opposite direction, then we will write A is equal to minus B. And what we understand from this? Their magnitudes are same, but their directions are opposite. So A unit vector will be equal to negative of B unit vector. Okay. So negative vector is clear. Unequal vector, right. So force, I am comparing with the force. If magnitudes are not equal, then vectors are called unequal. If directions are not same, then also they are called unequal. So for equality, these both conditions must match, then only they are called equal vector. If directions are same but the magnitudes are not matching, say B vector is having some different length, then I cannot write this equation. I cannot write this, I cannot write this, I cannot write this, if B is not having the same length as that of A. So for equality, their length must be same, their direction must be same. Okay. So I hope parallel, anti-parallel, equal, negative, both the terms are clear. Let's see next one. Collinear vector. So now again, they may or may not represent the same physical quantity. So two vectors, if they are acting along a line, maybe in same direction, maybe in opposite direction, they are called collinear vector, right. So two vectors are said to be collinear if they act on the same line. Now I hope this is simple definition, this is clear. Coplanar vector. So any two vector you take, say one vector in this direction, another vector in this direction. So I can make a plane on which both the vectors are lying. Problem comes if we have three vectors. So any two vector, if I take, any two vector will be coplanar. But if I take another vector, third vector, For them to be coplanar, all must lie on the same plane. So 3 or more vector are said to be coplanar if they lie on the same plane. So if all are acting on the same plane, then they are called coplanar. If they are acting on the same line, then they are called collinear vector. Now non-coplanar. Non-coplanar. From this definition itself it is clear what's the meaning of non-coplanar. If all are not lying on the same plane. For example, if I have one vector along x axis, another vector along y axis and one vector along z axis. So the vector which is along x axis, along y axis, they are coplanar, and the third one is not lying on the same plane. So they are non-coplanar, right? And one last point, movement of vector. Any vector can be moved parallel to itself without being affected. What does that mean? So if we have this as a vector, I can move this vector in forward direction and place it here. It will remain a vector. I can move this vector in backward direction, upward, downward. As long as I am keeping length same and the direction of vector same, the vector remains same. Vector will get only affected if I change the length, I increase the length of this one, now it will be something else, some b vector. Similarly, if I rotate keeping the length same, if I rotate it, so if I rotate keeping the length magnitude same, then it will become some other vector, c vector. So vector will get altered only if their magnitude is changed or their direction is changed. If keeping magnitude and direction we are shifting it parallel to itself, then vector remains same. So any vector you can easily move in the space and it will be represented by the same vector if magnitude and direction both are not changing. Okay. So these all names are clear, basic points are clear. Now let us get into the main discussion. I ask you ki if you have 2 kg potato and 3 kg potato, what is the total mass of the potato you have? So you can directly add 2 with 3, you will answer 5. Okay. But this is not the situation for vector. Like in significant figure we learn some rules to add 2 numbers or 2 measurement to report the answer. Similarly for addition, subtraction, multiplication we have got some rules for vectors also, right. So we will learn those rules to deal with vector quantity. So how to deal with the vector quantity? When we are going to add 2 vector, let us see. So say I have one vector p and another vector q and I want to add these 2 vector quantities. For example, 5 Newton force is acting in this direction and 2 Newton force is acting in this direction. Okay, 5 Newton force acts this way and 2 Newton force acts this way. Now these 2 I want to add. I cannot answer 5 plus 2 is equal to 7. How to answer it? Let us see. So after adding PQ, what I am going to get, that I will call resultant. So how to get the resultant? We have this triangle law of vector addition. So if you want to add 2 vector by triangle law, you have to arrange them in such a way so that tail of second vector coincides with the head of first vector and they are on the 2 sides of the triangle. Then the resultant is represented by third side of the triangle where the tail of resultant is placed on the tail of first vector and head of the resultant is placed on the head of second vector. So I hope this is very long statement, you are unable to understand, that is why it is written here. If the 2 vectors are represented by 2 sides of the triangle in magnitude and direction is taken in the same order, what is the meaning of same order, that I will tell. then the third side of the triangle is representing the magnitude and the direction of the resultant vector. Okay. So, if I have say one vector this way and we have got one vector this way, I want to add them by triangle law. What I will do, I will first try to arrange them in such a way so that tail of this vector comes over the head of this vector. Okay. So, I will rearrange it, and just now I told you you can shift vector parallel to itself. So, I shifted P, I am drawing it here. Then what I will do, I shift this Q vector in such a way so that this tail comes over head of this one, and according to the triangle law, the resultant is represented by line joining tail of first vector to head of the last vector. So, this is triangle law, right. So, what we are doing, P vector, we have got another vector Q vector, and then we want to find out resultant of these two. Resultant is represented by line joining tail of first vector to head of second vector, where arrow is kept on the head of second vector. So, this R is representing the resultant of addition of P and Q vector. Okay. So, this is one way of doing. There is one more way that I will tell later. Instead of 2 vector, if I have n number of vector, for example say 4 vector or 5 vector, then how to add? So, same logic I can extend to add more number of vectors. So, let us see polygon law. Order, one more point. Here I said one term is written, that is order. So, same sense if we are placing it, this is called order, right. If you put arrow of this one here, order will get reverse, right, that is order. Okay. Same thing here, if the number of vectors are represented by the sides of polygon both in magnitude and direction taken in order, their resultant is represented by closing side of the polygon taken in the reverse order in magnitude and direction. So, now we have got P, Q, R, P, Q, S and T, and I want to find the resultant of these vectors. So, R vector is P vector plus Q vector plus S vector plus T vector. Okay, so I want to find out the resultant of these 4 vectors. Triangle law, we have seen how to find out resultant of 2 vector. Now we have got 4 vectors and we need to add it. So, according to the statement, the resultant of these 4 vectors will be represented by line joining tail of first vector to head of last vector. So, this will be R, right. And if I just want to add P and Q, forget about P, Q, S, T, if I just want to add P and Q. So, if I just want to add P and Q, then resultant will be represented by this one. This is representing P vector plus Q vector. If I want to add PQS, only 3 vector, PQS, then tail of first vector to the head of last vector, only 3 vector I want to add, then this will be representing P plus Q plus S, right. So, now I think it is clear. So, this R is representing P, Q, S, T, only 2, by triangle law you can add. 3, triangle law, extension of triangle law is only polygon law, right. So, 3 vector polygon law, 4 vector polygon law. Okay. So, this concept is clear. if 4 vectors are given and when you start arranging them in such a way so that head of one vector lies over tail of another vector, if you keep arranging them and what you got is this P, then you place Q, then you placed S, then you place T, and you got head of T is coinciding with the tail of P. You can see that the gap between tail of this P and head of T, this gap is called resultant. But when the head of the last vector comes over tail of first vector, that means there is no gap now. So in this situation R is P Q S T, where R is coming 0 because there is no gap between head of T and tail of P. Here previous case there was a gap, so this gap was called resultant. There is no gap in this situation, so resultant will be 0. This is called null vector. Null vector. When you add vectors, you are going to get vector. When its value is 0, it is called null vector. Okay, so another name, another term, null vector, right? So we have seen triangle law and polygon law. Both are same. Polygon law is the extension of triangle law, where we want to add more than 2 vector. This is the procedure we need to follow. There is one more law to add 2 vectors, which is called parallelogram law. Okay. So previous case, or in case of when we want to add by triangle law, we were arranging vector in such a way so that head of one vector coincides to the tail of another vector. But in parallelogram law, we will arrange vector in such a way so that tail of both vector coincide and they will come parallel to the sides of parallelogram, right. So you will arrange 2 vector in such a way so that their tails are coinciding, then the resultant is given by the diagonal of parallelogram which passes through point of intersection of both the vector. Okay. So go through the statement once. If the 2 vectors are drawn from a point, okay, so that to represent the adjacent side of the parallelogram both in magnitude and direction, the diagonal of the parallelogram drawn from the same point means point of intersection, represents the resultant of 2 vectors both in magnitude and direction. Okay. So now I will arrange P and Q in such a way so that their tail will coincide, and they are representing 2 sides of diagonal, 2 sides of parallelogram. Name is parallelogram law, right. So parallel to this one, if I draw here, and similarly parallel to this one, if I draw here, I will get parallelogram, right. So according to the parallelogram law, the resultant of this, that means P plus Q is given by the diagonal of parallelogram passing through point of intersection, right. So this R is representing Q vector plus P vector. If you look closely, you can see triangle law also. If this is Q vector, I can move parallel to it. So this will be representing Q vector. Now see this triangle, P vector plus Q vector is giving you R vector. Same way I can move P parallel to itself, then this will become P vector, Q plus P will give you R, which is Q plus P. Okay. So triangle law or parallelogram law, any law you follow, you are going to get same result. Now the question is, if you know the magnitude of P and magnitude of Q, what would be the magnitude of resultant? I said 5 Newton in this direction and 2 Newton in this direction, 5 Newton in this direction, 2 Newton in this direction. what is the magnitude of the resultant? So, if R is a vector, if R is vector, then obviously it will have magnitude and it will have direction. What is the magnitude and the direction? That we need to find out. So, this quantity is having some magnitude, direction, this quantity having magnitude and direction, adding two vector will give you vector that must have some magnitude, that must have some direction. Magnitude is represented by length of this part. If magnitude of P is length of this part, magnitude of Q is length of this part, then length of this part will give you magnitude of R, right. So, using simple geometry we can find out the magnitude as well as direction. Let us see. So, let us calculate the magnitude when we add two vectors. So, R vector which is equal to P vector plus Q vector, and we want to find out R vector mod, which I am calling magnitude. Okay. So, P and Q when I add using parallelogram, then I will get R from here to here. This length I will call magnitude of P. Okay. Similarly, from here to here, this length I will call magnitude of Q. So, to calculate mod R, I need to find out this length, that is nothing but mod R. So, what I can do, if I drop perpendicular from here and extend this line. So, I extended this line and dropped perpendicular, this angle is 90 degree, okay. And let the angle between these two vector is theta. If this angle is theta, this side is parallel to this side, this angle will be equal to this angle, right. And this length will be equal to, as this is mod Q, this length will be mod Q. So, if I separately draw this triangle, then it will be more clear. Okay. So, I will separately draw the triangle. I am just drawing this part, right. So, this is 90 degree and here this length is Q vector mod, and let this distance be some y and this distance be x. So, if I ask what is sine theta from this triangle, sine theta. So, sine theta is equal to perpendicular upon hypotenuse y by mod q. From here what we have, y is equal to sine theta. Similarly, I can write cos theta. Cos theta is equal to x divided by mod q. That means x is equal to mod q cos theta. This length is x, which is coming mod q cos theta. That means this length from this triangle, you can see this is mod q cos theta, and this length is coming mod q sin theta, mod q sin theta. Okay. So, as this part is clear, I will remove this part. The simple triangle, this triangle I am talking about, this length I calculated, using simple trigonometry, right. Now, so these value I will use for mod R. So as you can see in this triangle, let's name them, let this be O, this be M, this be C, and this be some A. Okay, so just look at this triangle OCM. So for this triangle I can write OC whole square, Pythagoras, OC whole square will be CM square plus OM, OM square plus CM square. Right, nothing new. OM is what? From here to here, this distance is mod P plus mod Q, or I can write OM is equal to OA plus AM. So OM I can write OA plus AM. This whole square I can open, that will become OA square plus AM square plus 2 times OA AM. So if I open this bracket, then I am going to get this, and this CM is written here. I hope we can easily simplify. Now I'll substitute the value. What is OA? P. What is AM? What is AM? Mod Q cos theta. What is CM? Mod Q sin theta. So here CM is coming mod Q sin theta, this is coming mod Q sin theta whole square, and look at this one, AM is coming mod Q cos theta whole square and plus sign in between. So cos square theta plus sin square theta will give you 1. That means you are left with only Q square. When I simplify these two terms, I will get only Q square, right. So these two terms will give me Q square, and then this is giving me OA is P square. So here I will get P square plus 2 times OA, that is P, AM is Q cos theta, and then these two terms giving me Q square. So formula will be P square plus 2PQ cos theta Q square, right. So I will simplify and I will write it here. So R square is equal to P square Q square plus 2 PQ cos theta. So put under root on other side, R is equal to under root P square plus Q square plus 2 PQ cos theta. Actually this is written this way. This is R vector mod under root P vector mod whole square plus Q vector mod whole square plus 2 times mod P mod Q cos theta. So sometime instead of writing it this way, we directly write R is equal to P square plus Q square plus 2 PQ cos theta. Okay. Now here theta is angle between two vector. Angle between two vectors. So when you have two vectors, you can see that angle between two vector is one angle here and another angle here. So one is smaller, another one is bigger. Out of that you have to select the smaller one. So definition of angle between vector is when tail of two vectors are coinciding, out of two angle made, the least one is called angle between vector. Okay. So if I give you this situation, this is P vector and this is Q vector and this angle is 60 degree. What is the angle between vector? Angle between vector. Now first what you need to do, you have to make them in such a way so that their tails are coinciding. So you will extend this vector in forward direction, this will come this way Q, and this P is this way, and now we have two angles, one here, another here. The smaller one is called angle between vector, so this is theta. So in this situation that is coming 120 degree. Don't commit mistake in such small things. So I hope this angle is also clear. So arrange vector in such a way so that their tails are coinciding. Once tails are coinciding, two angles between vectors, the smaller one you have to take. Okay, so smaller one is the angle between vector provided their tails are coinciding. So this one is clear. Now we got magnitude. So out of this r, this is r vector mod, length of this one, and now direction. Direction we don't know. So for direction, same geometry I can use, right? Now let's see. So I need to define the direction of r. So as we already know the direction of p vector and q vector, with respect to p and q we define the direction. So if this angle is theta, with respect to p, let this angle is phi. So I can tell the direction of r with respect to p vector. Okay, so we already saw this is sin theta and this one was cos theta. Okay, O C M A. Again look at this triangle. So from this triangle I can write tan phi is equal to perpendicular CM divided by base OM. OM we can further break OA and AM. So OA and AM. Okay, let's substitute all the values. CM is mod q sin theta, OA is mod p, and this is mod q cos theta, right? Now this is the angle what we are getting, phi is equal to tan inverse this. This is the angle with respect to p vector towards q vector. Okay. Sometime we might be requiring angle with respect to q. Let this be some beta. Then I can write tan beta is equal to p sin theta divided by q plus p cos theta. So now if you want this angle, then you have to extend this vector and then draw perpendicular from here. This angle will be 90, and if this is 90, this will become p sin theta, this will become p cos theta, and then for beta, tan beta perpendicular upon base, perpendicular p sin theta divided by base, right? So be careful while writing the angle. You can keep this point in mind that when we are writing angle with respect to p, in numerator q is coming. When we are writing angle with respect to q, then numerator p is coming. When you are writing with respect to p, numerator q is coming. When we are writing with respect to q, numerator p is coming. Then you won't commit mistake. So this is with respect to q towards p vector. Okay, so you can use this formula or this formula depending on what is the requirement. So today we just learn how to add two vector either by triangle law or parallelogram law. So, magnitude formula and the direction formula what we have written here, these are important, these you need to remember. Okay. So, tomorrow's class we will discuss how to subtract two vector, right, and then we will talk about resolution of vector and the unit vector again once again. So, I hope you enjoyed today's class. Thanks very much for watching.